Hello, I present to you here the empirical rule by Table 18, Stats 210. What is the empirical rule? The empirical rule uses percentages of 68, 95, and 99.7 to describe where values lie on a curve, specifically the famous bell curve used in stats. So the 68% means that 68% of all observations are presented by the distribution that fall within one standard deviation, as below right here, 34.1, 34.1, this is that 68%. For 95% there will be about 95% that will fall within the two standard deviations for the mean. So it will fall between this standard deviation and this standard deviation on both sides of the bell curve. So this is your 95%. For 99.7%, there will be about 99.7% that will fall within three standard deviations of the mean. So between these three standard deviations, about 99.7% roughly with the symmetrical bell curve. Limitations in use. The empirical rule can only be used in normal distributions not skewed. Standard deviation must be calculated prior to using the empirical rule. The empirical rule is often used to predict data of an entire population that is not obtainable. Utilizing the graph 68, 95, 99.7, the rule numbers also correspond to the amount of space taken up underneath of the curve. So below are three different curves. This one has a positive skew, symmetrical distribution, and a negative skew. The symmetrical distribution is the only one in which we were able to use the empirical rule because of that distribution curve of the three standard deviations. This one we can't do or can't use because the mean, median, and mode are all at three different points on both, whether it's positive or negatively skewed. So that could create an issue, and also there's no symmetrical distribution of the three standard deviations. Examples where the empirical rule can be applied. The empirical rule can help forecast final outcomes in a set of data where the exact data is hard or impossible to obtain. It is always completely accurate, but the estimate is close enough. Examples include a study conducted on the usefulness on social media as an instruction. You know, you're not going to be able to go to random people because not everybody learns the same way. Some people it works well, some people it doesn't, but it's very hard to gather that type of information, but you can use the empirical to calculate whether or not it is or isn't. A study finding the effectiveness of teaching by certain professors at a university. You know, that's also subjective. It's a very subjective opinion, but it could fall. There could be a rating system in which you can rate a professor based on this bell curve, and a study of how well students perform on certain tests. You know, a curve is often used to describe the averages on certain tests. You know, there's a standard deviation from that average. There's usually 1, 2, or 3, depending on how well the students did on the test. And sometimes it'll be centered, you know, the average will sometimes be centered around a C, but sometimes it's centered around a D or an F, or so on. So the empirical rule can be used here very well. You know, it's often used to help curve exams to get the average up to work very nicely. A work example of the empirical rule. The average gorilla lives 16 years. The standard deviation is 1.7. Use the empirical rule. What is the probability of a gorilla living longer than 14.3 years? So below, 14.3 falls within that distribution right here. So in order to solve this problem, you'd have to add 34.5 in this region, 34.15 in this region, plus 34.15 in this region, plus 13.55, plus 2.15, plus 0.15. That will add up to 84.15%. This graph isn't labeled as well as I want it to be, but it is assumed that it's 34.15. You know, it's even distribution on the side, so it's where it's symmetrical distribution. So you have this, the same over here, same over here, and same over here on all sides. And that's how we did the math on solving that problem. The answer is 84.15%. And ladies and gentlemen, that is the empirical rule defined to the best it can be defined.